Welcome learners to Form 3 Mathematics. We are going to look at logarithms. And these are questions that have been tested in the past in KCSE. And for example, this one, it was tested in year 2001. And therefore, let us look at it. We are told that solve for x in the equation log x plus 24 minus 2 log 3 is equals to log 9 minus 2x. So how do you solve this? So solution, learner, solution. So the first thing that you do is to take these two up here to be the power of 3. You take these two to this so that every term starts with log. Every term starts with log. So you take these two to become the power of 3. So we write log x plus 24 minus log 3 squared is equals to log 9 minus 2x. So if you look at these three terms, learner, you'll see that they now start with the log. Then you move on and say log x plus 24 minus log what? 3 squared is 9 is equals to log 9 minus 2x. From there, learner, you apply a law of logarithm here. You can see that this is log of x plus 24 minus log of 9. If you have two logs and there is it's to do with subtraction, which law do you apply? This becomes log x plus 24, you divide by 9, learner. Look at this. If you have two logs and you're subtracting, you divide these terms here. This divide by this, as you just write one log according to the laws of logarithms. And therefore this will be equal to log 9 minus 2x. Log 9 minus 2x. So learner, if you look at our equation now, we have log on this side and log on this other side. You now drop out these logs, ignore them now, and therefore you end up with an algebraic equation which looks like that. So you drop out logs if they appear on both sides of the equal to sign. From there, learner, cross multiply now, cross multiply. So you have x plus 24 is equals to 9 into brackets 9 minus 2x. And therefore this is x plus 24 is equals to what? 9 times 9 is 81. You remove the bracket and this is minus 18x. From there, you put the like terms together, bring minus 18 on this side, minus 18x on this side, and take this to the other side. So you get x plus 18x is equals to 81 minus 24. This gives you what? 19x is equals to 57. 19x is equals to 57. Divide both sides by 19, learner. Divide both sides by 19, and therefore our x is equals to 3. And that is the answer. So learner, the idea here is that you first take these two to become the power of 3 according to a law of logarithm, and therefore we see it here. From there you apply another law of logarithm here. When you have two logs and you are subtracting, you just write one log and you divide these two terms. From there, drop out the logs, you get an algebraic equation. Cross multiply, put the like terms together, and finally your x is 3. Let us look at another example. Let us look at another example, still to do with KCSE problems. Let us look at this, learner. Find the value of x given that log x minus 1 to base 10 plus 2 is equals to log 3x plus 2 to base 10 plus log 25. This was a KCSE problem in year 2015. So how do you solve this? How do you solve this? So solution. The first thing, learner, in this problem is to check on your terms. This term here has log with it. This one is just a 2. So you need to write these 2 in terms of log. Express 2 in terms of log. Here, this other one has its log, and also this one has the log. So the first thing is to replace this with the log. Maybe I can write that. Replace this with log, or express it in terms of log. So how do you do this, learner? You say, let log y to base 10. If you look at this equation, it is to base 10. So we assume let log y to base 10 be equals to this 2 here, learner. Look at that. Let log y to base 10 be equals to this 2. So from here, learner, what is your y? What is your y? You say y is equals to, the base is 10, you write it here, and you raise it to this 2. Okay, so log y to base 10 is equals to 2. So what is y? To get y, you write everything now in index notation, what we call index notation. So y, learner, is equals to, your base was 10, you write it here, and then you raise it to this number. So your y, learner, is 100. And therefore, our log, in this case, will be log 100 to base 10, log 100 to base 10, and therefore it is the one that we are going to fix here to replace where the 2 is. And therefore we write our equation now, log to base 10 of x minus 1 plus our log 100 to base 10 is equals to log 3x plus 2 to base 10, okay, plus log 25. Look at that, learner. We have replaced our 2 with a log 100 to base 10. From here now you apply the laws of logarithm. Here we have addition, and here we have log of this and log of this. If we have addition, learner, we normally write 1 log, and then what do we do to these 2 terms? We multiply them. And therefore you take your 100, this one, you multiply with the first one there. And all these are to base 10. So if you have 2 logs that you're adding, you write 1 log, then you multiply this number times that. Therefore, you move to the other side, you do the same. Log of this plus log of this, learner, you write 1 log, just like we've done on the other side, then you multiply these 2 terms. So 25 in brackets, 3x plus what? Plus 2. Good. So from there, learner, you look at your equation. You have logs on both sides of the equal to sign. Drop them, just like we did in the other one. Drop these 2 logs, and therefore you end up with 100 minus, 100 in brackets x minus 1 is equals to 25 in brackets 3x plus 2. Remove the brackets, learner. So this gives you that is equals to what? 75x plus 50. Put the like terms together. Put the like terms together. So 100x minus 75x is equals to 50. 50 plus 100. 50 plus 100. Subtract this, learner. You'll get 25x is equals to 150. And therefore, learner, to get x, you just divide both sides by what? By 25. And therefore your x will be 6. Good. So learner, go and practice on how to solve logarithmic equations. This is Form 3 work. Go and practice. God bless you.